Hello,
Yes, ma'am.
sir.
Is it visible, ma'am?
Yeah. Okay. Okay.
Yes,
Fine.
clear.
Yeah. Okay.
You
This
can begin.
this slide is moving.
Yeah, moving, ma'am.
Okay. Okay. Hi all. Good morning. I'm Panchami. I'm from the CC Cybersecurity Department of IIIT Kottayam. Today, I'm going to discuss about the fundamentals of blockchain and cryptocurrency. So, throughout the lecture, I am explaining the concepts of blockchain through a particular application called finance, which is the cryptocurrency. Before starting to the fundamentals of blockchain, so let's start just analyze the evolution of blockchain technology. So while we consider the evolution of blockchain technology, we can classify its blockchain 1.0, 2.0, 3.0, and 4.0. So if we consider the period, say if we consider the period, it's 2000, the blockchain to 1.0 starting from 2013 to 2015. Okay. So, um, pardon. So, this is all along blockchain 2.0. So, the 1.0 started from 2008 to 2013, where Satoshi Nakamoto introduced Bitcoin. So, it's blockchain 1.0 started from 2008 to 30. 2.0 start from 2013 to 50. Then 3.0 it start from 2016 to 2018. So the next is the last phase, we call it as 4.0. So it starts from 2018 till date. Okay. So while we consider the evolution of blockchain technology, just we discuss 1.0, 2.0, 3.0, and 4.0. 1.0 started from 2008 to 2013, where Satoshi Nakamoto, who is an anonymous author and the creator of Bitcoin. You may heard about Bitcoins, right? So it plays or it captures around 90 percentage of the market, where the bitcoin was introduced by an anonymous creator called Satoshi Nakamoto, and that was in the year of 2008, so through a white paper, and that white paper went viral. Okay, soon after one year, which is in 2009, he really introduced the real bitcoins towards the market, where he pushed around 50 bitcoins towards the market. So that happens in 2009. So while we consider the evolution, we just started from 2018 to 30. While we consider 1.0, that era, it's more about cryptocurrency, or it's more about finance. Okay, when we talk or people talks about blockchain, the only application of the blockchain is finance. That is the cryptocurrency, where we have the digital currency. Okay, here in this part you may heard about you may see about different keywords like distributed ledger, merkle tree, blockchain, data, proof of work. So everything is the part of the very basics of the blockchain that we are going to discuss in the coming few hours. Okay, so here the blockchain. Yeah. So here the blockchain 1.0, it's all about the cryptocurrency and money and all about payment transactions. When we come across through 2.0, here there is the major innovation is that in the introduction of smart contracts. So smart contracts is nothing but it's a program where you can write the business logic in that using that program. You particular programming language is Solidity. So there, through smart contract, people started using this blockchain technology for other application. Okay, and especially speaking, when we compare 1.0 with 2.0, 1.0 means asset, means it's all about money. When it comes to blockchain 2.0, anything could be asset, whether you have a digital painting or any gold or artifacts. So anything you can be assetized, we call it as tokenized towards the blockchain. So anything you feel that it is an asset that can be converted into a token with respect to blockchain. So that means the blockchain, that technology has been utilized for different other application through the concept of smart contracts. And that happens as part of 2.0. While we consider 2.0, this is the era, 2013 to 2015. Even if we are utilizing blockchain for other application or for assetization, it's still considered as a futuristic technology. Okay. Then comes blockchain 3.0. Blockchain 3.0, before going to discuss, we are very familiar about mobile apps, web apps, right? So, how you define those applications where we have a front end, we will interact with the front end, and the back end will be normally a database, right? So here, as part of 3.0, where it started from 2016 to 2018, people started creating decentralized apps. So one of the major innovation here as part of 3.0 is decentralized apps, just like your mobile app or a web app, where there will be a front end, and the next to it is it's the smart contract. So you through front end you can interact with the blockchain. So the back end is blockchain. Okay, so whatever the data you are giving, it will be stored in the blockchain. So when we consider in a mobile app, you have a front end, right? So the front end, through the front end, the data will be storing in a server or in a database, right? Database will be the backend side, or even if a cloud. But when it comes to decentralized app, obviously the normal web-based front end or a mobile-based front end, behind that the smart contract will be there, the program. So through the smart contract, we are inputting your data as well towards the blockchain. So the backend will be blockchain, front end it will be there. In between the backend and the front end, there comes the smart contract. Okay, smart contract is nothing but the program where we can write the uh, business logic. Okay, whatever the conditions we can come up with, we can write over there. And this smart contract is also immutable. Okay, immutable, that we are discussing. Whatever the data we are storing in the blockchain, if you try to tamper the data, if you try to modify the data, the moment the whole chain becomes invalid. Okay, so similarly, the smart contract also, it is public, and it is also terms to be or claims to be immutable, because the smart contract, even if this is a program, it is deployed on blockchain. As it is deployed on blockchain, we cannot tamper the data. Okay, the moment we tamper, everything becomes invalid. So that's the evolution of as that's the innovation as part of the blockchain 3.0. When it comes to industry, that we call it as the blockchain 4.0, where in the 4.0 industry started using this blockchain technology for their business. For example, you can use blockchain for supply chain management, medical, healthcare, or smart grids. Nowadays we are using IoT, we are integrating with IoT. Any domain you can integrate with blockchain, so that a transparency, security of the data will be there, uh, and so efficient transaction will be done. So these are the few advantages of the blockchain where industry started utilizing this technology. So when it comes to blockchain 4.0, it's not at all a futuristic technology. It's already being used by industry or the organizations. Okay, so that is the evolution of blockchain. So we started in 2008, as soon as Satoshi Nakamoto introduced the Bitcoin, where when it comes to first phase, okay, 1.0, it's all about cryptocurrency. When it comes to 2.0, as soon as the smart contracts are introduced, there people started utilizing for other application. as well as anything could be assetized to blockchain. And one more point, one more important happens at 2.0, where Ethereum was introduced. Okay, Voltaic Buterin, he's the creator of Ethereum. Ethereum is a blockchain. Okay, so Bitcoin is a cryptocurrency. At the same time, we need a chain, right? Which need a network. So the network and the cryptocurrency is known as under the same name called Bitcoin. When it comes to Ethereum, Ethereum is yet another blockchain. Okay, Ethereum, it has its own cryptocurrency, where you may heard about Polygon, right? Polygon is also a blockchain, and the cryptocurrency associated with Polygon is Matic. When it comes to Ethereum, the cryptocurrency is Ether. So every blockchain has its own cryptocurrency. Particularly speaking, every public blockchains. Okay, so apart from that, there will be hybrid or consortium blockchains are there, but when we are talking about, or we are concentrating in the public blockchain. So public blockchain is the only blockchain which has its own native cryptocurrency. So Bitcoin, when you tell about, or when you discuss about Bitcoin, it's a cryptocurrency, but to transfer cryptocurrency, we need a network, or we need a technology, right? So the technology and the cryptocurrency is known under the same name called Bitcoin. So this Ethereum, which is introduced as part of 2.0, what's the advantage of Ethereum is that Ethereum is developer friendly. Okay, but Bitcoin network or Bitcoin chain is not developer friendly. So that's the reason why Vitalik Buterin, in the year of 2013, he introduced Ethereum, which is a public blockchain. For as it is a public blockchain, this native cryptocurrency Ether is being used. So now we consider Polygon, right? Polygon is another blockchain which is built over Ethereum, and the cryptocurrency associated is Matic. So there will be numerous crypto blockchains are available, public blockchains are available, each having their own name, and native currencies are associated with that. Okay. So that is the part of 2.0. 3.0, they are introduced the decentralized app, just like your mobile phone or a web app, where the only difference is that the backend will be the blockchain. So whatever the data you are inputting through the front end, it will be stored in the blockchain. So that's the D apps, decentralized app. And when it comes to 4.0, industry started utilizing this wonderful technology. And so as they have started for supply chain management or smart grids, IoTs, everything they have used. Okay, so this is the evolution of blockchain technology. Is the slide is moving?
Yes, ma'am.
Hello? Yeah. So now I'm in the application of blockchain, isn't it? Hello? Okay. So next is while considering the application of blockchain, here we have, you can see that there are different domains, right? One is from finance, and the banking, Internet of Things, healthcare, supply chain. So different domains are over here. So here we can integrate blockchain technology in all these domains. As I said, if we consider this power grids, okay, you can power grids. You can integrate blockchain technology with the power grids in such a way that it act as a decentralized platform for generating and sharing powers. Okay. When it comes to crowdfunding, okay, you can see there is a crowdfunding, right? That means, say, if I want to, I'm an entrepreneur, and I want to develop a project. Okay, so as part of my project, I need funds from angel funding, or so I need fund to come up with that project. Okay, So in that way, what I could do is that I can create a decentralized app where, especially speaking, I can create my own smart contract, which is a program. So I can write the logic in such a way that, say, the minimum
right. Okay.
investment that you have to do is $50 or $100. So if anybody tried to deposit that amount, less than that amount, it can't be a successful transaction. So these sort of conditions, right? And another condition, it could be to develop that project, I need $10 million. Okay, so the moment I receive, or that particular application receive $10 million, nobody can't invest more money towards the smart contract. So then there's a question that whether smart contract is a program, whether this program can hold money, isn't it? So yes, this smart contract has special programs which is deployed in the blockchain and they can hold money. Okay, and just like a variable, you are very familiar with programming, right? So variables can hold data. So similarly, that we can create variables and they can hold money as well. Okay, so in that way, these are some business logic, and that the particular application which I have narrated to you is a crowdfunding. So you can see that whatever the funding happened towards that particular application or towards that smart contract, it will be visible for everybody. So if I am an investor, I can see that where my money is being stored, whether my money is being utilized by that particular person for the correct purpose, whether whether he has or she has utilized for exactly for the project itself, how much money is being utilized, whether it's on the track or not. For example, if I have utilized that amount of money for some other purpose, the moment the smart contract becomes invalid, or they can or write we can write the logic in such a way that if I have utilized the money for some other purpose, the rest or the money will be re or it will be returned towards the investor's account. So these sort of business logic we can apply, or we can code in the smart contract and apply it in different application. Especially the application which I have narrated to you is the crowdfunding. Okay, so banking application that we are concentrating in the throughout lectures, how much we can utilize the blockchain technology for the banking application through the concept of cryptocurrency, that we are discussing in a very detailed way. Apart from that, Internet of Things, it's everything now we can connect to internet, right? So irrespective of electronic or non-electronic, everything we can connect. So the data which is coming from the Internet of Things is continuous, and this data could be saved in a blockchain. Okay, so in that fact, the blockchain will act as a backend side where everybody who are acting or who are the users can view what's the data. Okay, as per that, actuation may happen. So supply chain, we are all familiar with the supply chain where online we are purchasing online products through Amazon or Flipkart. So you can see that these companies are utilizing blockchain to ensure that whether our product is being reached by the particular client in a correct way. For example, Walmart, right? It's the who are the major uh, um, wholesalers in the supply chain market. So on one part, they are facing so many return rates, so that they have to reimburse or they have to refund the amount towards the client. So what the Walmart will do, they have done is that in the year of 2018, so they have introduced blockchain technology in their supply chain management system. So the moment they have implemented, what happens is that, as you know, that from the supply chain is that from the farm towards the warehouse, from the warehouse towards the distribution centers, then ultimately it may reaches the client, right? So there are different phases. In each phase, we are creating blocks. So whenever there is any tampering of the data happens, or tampering in the sense in the real time application, say if the product becomes faulty, okay, so it will changes the block. So ultimately what happens is that it will pushes a red flag saying that towards the vendors or towards a client, we can easily track where your product is, yeah, what happens to your product, whether this product is being reached by the client in a very good way, quality is being preserved, so that that company Walmart have they come up with a huge amount of profit soon after they have introduced the blockchain technology. So that this is the application of blockchain technology when it comes to industry. Okay, so overall these are the different other applications. Next, we are going in a very detailed way about the blockchain. Before that, we will discuss why we need blockchains, right? So, as I said, we are discussing about the finance application, especially in the banking sector. Here, you can see whatever we are all using banking, right? Mobile banking or UPIs we are using, right? So, this is the normal conventional banking. And here, when it comes to blockchain, let's have a comparison. The first thing is that if, say, this is Alice, and here we have Bob. Alice is residing in some, say, in India, and Bob is from America. And if Alice want to send some amount of money to Bob, first she want to convert it into the native currency or that Bob wants to. Okay, so some in between Alice and Bob, she can't directly send money to Bob. In between, there will be a central authority or a financial institution. We call it as banks. So through the banks, we are she is going to send the money. Okay. So here the problem is that there will be a transaction fee. This bank or the financial institution will enable some transaction fee. So some percentage of money will be given to this financial institute or financial organization to make this service. What's the service they are doing? They are transferring our money to our relative or family or whoever we have to send to them, right? So the first thing is that there will be a high transaction fee. The second thing, there are chances that double spending may happen. Double spending is the scenario in which if Alice tried to send same amount of money to Bob as well as some other user called Daniel or somebody. Okay. So that double spending is the scenario in which if Alice tried to spend same amount of money to two different persons at the same time. So that's a problem. Okay, so double spending happened because one is intentional, another is unintentional. Unintentional means if she tried to tamper the button twice, maybe because of the poor internet connectivity, and she can't analyze that whether it is being gone from his account or not. So that may happen, right? It's the part of an unintentional double spending process. Okay, so so that's a problem. Intentionally our bank will do, or they have their own mechanism to prevent double spending. But in earlier maybe 10 years back and all, from ATMs double spending problems are being reported a lot, but nowadays those sort of problems are not there. So double spending is still a problem when it comes to a conventional banking. Next is frauds. Frauds are there even if you introduce any kind of technology, even if blockchain is there, frauds will be there. They are very smart. According to their smartness, they will go for major attacks and all. Okay, say frauds here we are getting a lot of calls or messages or mails to share our credentials. Don't share our credential here. The frauds in the sense, as you can see that this is centralized, right? So all the data are being stored over here. So this is the third party who is storing our data. Okay, so if the frauds are very intelligent, or if they are smart, and if they attack this database of this particular bank, right? As if this is centralized, they can get our data. So instead of some 10 lakh, if they reduce or if they deleted 3 4 zeros, what happens ultimately? We will lose our money, right? So based on the smartness or their skill set, they can play any sort of attacks. Okay, so that's one of the major problems. The third point is that I have already mentioned that this is a centralized approach where all our data are being stored in a central. Of course, there will be a server, and they are taking backups as well. Our banks are coming up with great security, and they do have good backups. But the problem is that the hilarious thing is that this is our own data, right? Our data, we are asking to get our data to a third party. Just consider, maybe because of a catastrophic thing happen, or to some power failure, or something happen. And if such things are happening, this bank, of course they are taking backups. And if we have to give some request to get our data, and it may takes weeks, months to get our data, if because of this poor data recovery. Because why this is poor data recovery? Because all the data are being stored in a centralized way. Okay, so in that way, even if backups are there, we have to wait for a quite long time, like for days or weeks, or even if something happened wrongly. Okay, so the point is that it's our own data, and we are requesting to a third party to get our data. So that's because of the centralized approach. So on one hand, we have the conventional uh, transaction, which is done with the help of banks or any financial institution, where these are the problems that we are currently facing. So these problems we call it as the money transfer problem. Okay, high transaction fee. That means some amount of money should be given to the third party. Double spending is there. Network frauds will be there. As this is a centralized approach, there will be always poor data recovery. So on one other hand, blockchains. Even if blockchains are there, we cannot claim that there is no transaction fee. Yes, it's all about business. But when we compare, there will be minimal transaction fee. So one is minimal transaction fee. The second one is that the probability of having double spending is very less. Okay. The third point, network frauds. I have already discussed you that even if you come up with a blockchain technology, network frauds are there. But if you try to tamper the data, or what happens, that the network fraud will try to tamper the data, right? So the moment you tamper the data, the whole blockchain becomes invalid. So the concept of blockchain is that there is no central authority over here. So who will validate your transaction? It is correct. Here we have a central authority saying that yes, the transaction initiated by Alice is correct or not. But in this case, there is no central authority to validate your transaction, and where we will store our data. There are two questions, right? The first question, the first answer is that the validity of a transaction, say this is Alice and here it is Bob. If Alice initiated a transaction, the validity is done by the nodes itself. Okay, or even Bob also can connect. And there are some special nodes who can validate the transactions. Okay, we call it as miners. So the nodes themselves will be the validators of the transactions initiated by other nodes. The second answer is that who okay, so what happens if somebody try to tamper the data? Okay, or the second question is that where we will store the data, right? The data are being stored in each node. That means, for example, Alice is a node, right? Alice is storing not only her own data, she can view Daniels, Bob's, whoever joining to this network, there the whole data can be visible to everybody in the network. Okay, of course, privacy is not being preserved. Nowadays, privacy is also preserved with the help of zero knowledge proofs. Okay, so here the point is that the data are being stored in each node. For example, if we are joining to a blockchain network, so that means we are a node and we can store the whole data, not only our own data. We can see what's the balance of others, what they have done, what's the transactions they have done, and based on that, double spending scenario is not at all possible in the case of blockchain. Network frauds, if a node becomes malicious, or if some attackers are just injected or just added to the network, the moment what's their intention is that they will try to tamper the data, or they can loot the money, right? So the moment they tamper, or the moment they try to modify the data which is stored in the blockchain, the whole blockchain that the party is holding will becomes invalid. Okay. Poor data recovery, there is no issue of poor data recovery, because every node who is being the part of the chain, they are holding entire data. So there is no matter of that point called poor data recovery. Okay. So so this is the that's the reason why we are moving towards the blockchain technology. So before going to blockchain technology, one more point I want to address is that blockchain and Bitcoin, or any cryptocurrency that you are familiar, is different from blockchain technology. So Bitcoin or any cryptocurrency is just a digital currency that we are utilizing to send from one party to another, irrespective of the geographical condition or geographical area, in a decentralized manner with minimal transaction fee. So Bitcoin is a digital currency where we can send money from one party to another in a decentralized way with minimal transaction fee. So if you want to transfer the money from one person to another, we need a technology, right? So the technology is the blockchain. So blockchain technology, which enables you to transfer the digital currency from one person to another. So that is blockchain technology. Okay. For example, Ethereum is a blockchain. Bitcoin itself is a blockchain. But when it comes to Bitcoin, we say that it is the Bitcoin network. Bitcoin network. So Bitcoin network is the blockchain, but the cryptocurrency we call it as Bitcoin. So the network and the cryptocurrency, it comes under the same name called Bitcoin. So when it comes to Ethereum, it is the blockchain, and the cryptocurrency is no, Gigi. The cryptocurrency is Ether. Okay, so the cryptocurrency is Ether, and say another is Polygon. Okay, Polygon is another blockchain, and the cryptocurrency used is Matic. So these networks, or these are blockchains which is different from the cryptocurrency. So what's the relationship is that if you want to transfer cryptocurrency, or if the digital currency want to work properly, there should be a need of a technology, the technology which enables you to transfer the cryptocurrency or the digital currency from one person is to another. We call it as blockchain. So Bitcoin network is a blockchain, Ethereum is a blockchain, Polygon is a blockchain, and these are all public blockchains. Public blockchain means every data, okay, whoever joining to this chain, every data is public. So there is a problem here is, the privacy is a problem, because on other hand, your conventional the transaction, right? When we go ahead with banks and all, bank is preserving privacy for your data, isn't it? We cannot know that how much other party is holding, what are the transactions they are doing, we don't know, right? So privacy is being preserved in banking, as well as we are very familiar with UPIs. Per second, millions of transactions are being happened, right? So what's the disadvantage of the public blockchain is that, disadvantage, we cannot say disadvantage. Yes, privacy can be preserved in blockchain with the help of zero knowledge proofs. And the next point is that, yeah, one of the important point is the scalability. That means in blockchain we cannot do millions and billions of transaction per second. Okay, that we cannot possible. That stage we do not reach. Okay, the moment we reach over there, we call it as scalability. We can use this blockchain as a normal UPI or any banking sector. So that's a few limitations of the blockchain technology. Okay, per second now it's reached like 1 lakh transactions. When it comes to Ethereum, it's like maximum one lakh transaction. It is possible in per second. Okay, so we can nutshell in such a way that blockchain is not Bitcoin. Blockchain is not just about cryptocurrency, because we can apply this blockchain technology in different other applications as well. Now we are moving towards the uh, blockchain technology. Okay, so how you explain blockchain? Blockchain is a cryptographically secure, distributed open ledger. So this is the definition of cryptographically secure. How it is cryptographically secure? Because the moment we try to tamper the data, what happens is that the whole chain becomes invalid. Okay, so that we will explain in the coming few slides. But mostly firstly we will concentrate on what is distributed open ledger. Okay, so for that purpose, just assume there is a network where only four members are there, but in real scenario, millions and billions of nodes are in the network. So here we have only four nodes. Say this is Alice, Bob, Catherine, and Daniel, where we have to discuss what is distributed open ledger. Ledger means we can store the transactions in ledger. Okay. Open means it is available for everybody who is participating in the network. For example, say this is Alice. Alice is holding some 10 Bitcoin. Okay, so in this way, if Alice want to spend some 5 Bitcoin to Bob. Okay, and this is a transaction, and that transaction will be recorded as part of the ledger. So Alice to Bob, how many Bitcoin? 5 Bitcoin. How much Alice is storing? Alice is storing 10 Bitcoin. So everything will be stored in a ledger, and it is open for everyone, which is publicly available for everyone. That means Bob can see that how much Alice is holding, what are the transactions done by Alice. Similarly, not only Bob, Catherine as well as Daniel will can view every data with respect to every node in this network. Okay, if suppose Bob is sending some 3 Bitcoins to Catherine. Okay, so in that stage, everybody, the moment this transaction is initiated, what happens is, so this becomes, just assume this is a block, and okay. So the moment one party initiated a transaction, everybody can see that, yeah, there is a transaction initiated by Bob, and they can validate the transaction. How they can validate? Because in this case, we can say that, say Bob is holding 5 out of 5, he can spend 3. So in that way, the validity is being checked, and in that way itself, this double spending is being there won't be any double spended transactions which will be added as part of this open ledger. Say if Bob to Catherine, how many Bitcoin? 3 Bitcoin. So if Catherine tried to spend some 10 Bitcoin, so does this transaction be the part of this open ledger? No, because everybody in the network can view or analyze that this Catherine doesn't have enough money to spend 10 Bitcoin to Daniel, so that that transaction won't become the part of the open ledger. So in that way, double spending or invalid transactions won't be the part of this open ledger. If next is if Catherine tried to spend one Bitcoin, yes, of course, as Catherine has enough money, that means to spend one, so that this will be the part of the open ledger. Okay, so this is the open ledger. Ledger means every transaction will be recorded and stored. Open means which is publicly available for every participants in the network. That means how much each party is holding, what are the transactions that done by everybody, that will be saved in this open ledger. Is it distributed? Is this in this scenario what we have now, it is distributed? No, because still it is in the decentralized way, right? If you want to say distributed, that means the copy of the open ledger will be stored as part of Alice, Bob, Catherine, and Daniel. Okay, so now this is distributed. So there will be a problem over here. What will be the problem? The problem is that synchronization problem, because the network itself want to ensure that the same copy of the blockchain is being stored at each node side, and that will be done with the help of the mining process that we are going to discuss. Okay. So now I think you are okay with this open distributed open ledger, isn't it? Next is next we are going to the security aspects and all. We just want to what is blockchain, okay? In a very deeper way, blockchain is means it's a chain of blocks. You can see this is a chain of blocks, isn't it? So block means what some data will be stored in this block. What are the data associated with each block? Okay, it's just like a linked list. It's a, like you are very familiar with the data structure, like it's just like a linked list. And here the block consists of previous hash, transaction data, and nouns and hash value. I think you are familiar with the cryptographic aspects. Hash means it's a cryptographic function. It's a one-way function. We are very familiar with functions, right? So arithmetic functions we are familiar. So this is a cryptographic function. Okay. So we have to input something so that it will gives you an output. Um, the specialty of the hash functions are these are all one way function. Okay, that means the moment we get the, it is infeasible to get the input from the output. Inverse is infeasible. Okay. You may heard about encryption algorithm, encryption functions, right? Encryptions are two-way function, because the moment you input, you will get output. So there will be an inverse function called decryption function, so that if you put output, it will give you the same input. So encryption is a cryptographic function, but it is a two-way function. But hashes are one-way function, so that it will gives you output. From the output you cannot go back, you cannot get the input. Okay, so we can say what's the application of the hash function over here in the blocks is that we are utilizing these hashes for identification. Okay, for example, there are few properties for the hashes, right? For a particular input, say input 1, it will gives you output 1. Okay, so for input 2, it will always gives you an output 2. So it's a one to one function. Okay, so that you can clearly identify a particular input with this hash function. Okay, for example, Aadhaar card, right? or your roll number or your register number. These are all identifications or that you authenticate. Of course, it's an authentication method. Especially, it will gives you to identify uniquely, right? So, in order to identify a block uniquely, we can utilize this hashes. So, there will be a hash function. Okay, so in when it comes to Bitcoin, we are using SHA-256 function. It's a particular hash function, but in Ethereum we are using Kekak. It's another hash function. Okay, so we have to input some data to this hash function so that it will gives you a hash code. Okay, so this hash code, so there will be a unique hash code for every blocks. Okay, so what are the data that we are inputting? So the first data will be each block having a block number. Okay, and the timestamp. Okay, a timestamp in the sense the date and time in which the blocks are being created. So these are some data, but the crucial data is that there will be a previous hash. So just assume that this is the first block. Do any previous block is available? No, right? So as there is no previous block for the first block, the previous hash will be all zeros. Okay, so there will be a previous hash. So the first block in the blockchain we call it as Genesis block. So according to a Genesis block, there won't be any previous block, so that the previous hash will be the value of the previous hash will be all zeros. So that will be one input. Another input, your transaction data. Not exactly like only one transaction per block. You can accommodate multiple transaction in a single block. So each block have some maximum size like 1 MB. Okay, 1 MB. So accordingly you can accommodate how many number of transaction. Okay, so it's not exactly like a fixed number of transaction per block, because transactions vary, the size of the transaction varies. Okay, in that way, the moment the block reaches 1 MB, you can limit your number of transactions. So, but the point I want to convey over here is that you can accommodate multiple transactions in a single block. There are chances that you can, for one per transaction per blocks are will be there. So there are chances, because that number of size will be there for a particular transaction. So in reality, this is like multiple transaction will be the part of a single block. So transaction data, then nouns. Nouns is a random number. For example, for each block, we have to generate unique value, right? So in order to generate unique value, there will be a nouns, which is a random number, just like this is a random number. Once we use this particular number, okay, it's just an example. Once you use a particular number, we don't reuse that number for other blocks. Okay, so nouns is a random number which we are utilizing to generate the block hash. Block hash is always unique, so that while using block hash, you can easily identify a particular block. Okay, so what are the major points? The points are, according to a block, there will be a previous hash, transaction data, nouns. Okay, previous hash is the hash of the previous block. Transaction data, or from Alice to Bob 10 Bitcoin is a transaction data. It's not exactly like we can accommodate multiple transaction data in a single block. Nouns is a random number, where once we use a particular value, we don't reuse that value. So if you input, apart from these major components, we can input block number, timestamp, everything will be given to a SHA-256 function in the Bitcoin, so that a block hash is being created. So each block is associated with four things: hash of the previous block, transaction data, nouns, and the hash of the block itself. So hash of the block means it is a unique identifier for the block. Okay. Yeah. So now you can see that when you go across different explanations of blockchain, blockchain is a distributed public database of immutable records called blocks, which is secure with blockchain. That means we are saying that it is everything is immutable, right? That means if somebody tried to tamper the data, okay, what happens? You know that hash function, there if there will be a one input, it will always give you a particular output, right? So if you try to tamper the data, tamper means you are changing the input, right? What happens? It will give you some other output. So if you try to tamper the data, what happens? The block hash will change. It will like A3BC, okay, B6. Okay, if you try to tamper the data, the block hash will becomes it will gives you some other block hash. If you compare the block, this particular hash with the previous hash of block 3, it is completely different, right? So what happens is that not only this particular block, the entire chain becomes invalid. And that's one of the reason why we are stating that immutability is achieved with the help of this in blockchain, okay, because of this hash. That's a one reason, okay. If you try to tamper the data, block hash will change. Not only that particular block, the entire block hash will changes. Okay, so what happens? The entire chain becomes invalid. Next is about the demonstration. Demonstration. Yeah. So regarding the demonstration, I will show what I have communicated with you. So theoretically, say if I'm saying that this is data, say SHA-256 function. Okay. So I am inputting data. Hi, how are you? Okay. So each time you can see, each time I am inputting data, you can see that the hashes are being changed, right? Okay, so you can see that this hash, this particular hash, say 59E9F4, this hash will be a unique identifier for your data. And this property is being utilized in the blockchain. Okay, so that's the specialty of the hash. So while getting the hash, it's like a random alphanumeric value, right? This is SHA-256 means it will give you a 256 bit output. Okay, so if you convert it into bytes, okay, you will get a 32 byte data. So this is a 32 alphanumeric value, which will be a unique identifier for your data. So, and there are few other properties of hashes as well, right? The when we compare the data with the hashes, it is always, the hash code is always smaller than the data, right? Isn't it? It's not like always, but the point is that uh, your data, the length of your data or the size of your data may varies, but the hash value will always give you a fixed sized output. If we are using SHA-256, it will give you 256 bit output. If you convert into 256 into byte, there will be 32 bytes, right? So it will always give you a fixed output. It's a one-way function. That means one somebody got this hash code, you cannot get the data back. It is infeasible to get the data back. Now we are moving towards the block. Block means, of course, there will be a block number. Nouns, you can see that this is the nouns value, which is a random number. Once we use this nouns value, we cannot reuse it because we want to preserve the hash code of a block uniquely, right? Next is another point I want to convey to you is that just analyze the block hash, how it looks like. Some zeros are in front of this alphanumeric value, right? So this This is a normal hash. But if you come up with a block hash, some zeros are in front of this block hash. That means the number of zeros, uh, the number of zeros increases. The mining of a particular block is also the effort to mine a particular block is also increases. Then what is mining, right? For example, say I have initiated a transaction and that transaction is flooded across the network. So this transaction, just assume that I have initiated a transaction, it is converted into a block, and at that particular stage, the block is not at all accepted or not at all being the part of the blockchain. So before, if I want to say that a newly created block means some new transaction is added as part of a block, right? So first of all, the nodes in the network want to validate that the block is valid. Once it is valid, it has to be added as part of the chain. So who will do? And what's the process known as? The whole process is known as mining. There are some special nodes in the network we call it as miners who is actually validating the block. Okay, how they are validating? Because they are validating through the process of mining. For example, say if I try to tamper the block, what happens? The block hash is changed, right? Now this is a graphics where you can see that the tampering is just initiated, like narrated with the help of this pink color. If I have to go for mining to make this block a valid block. Okay, so my point is that if a particular block is invalid, you can try to validate the block with the help of mining process. So this is mining. What is mining process? Okay, so after mining process, you can see that even if I have tampered the data, some block hash is being changed, but the block hash, some zeros are there. So mining is a, in Bitcoin, the process is done with the help of proof of a consensus algorithm, where what exactly it is doing is there will be a block hash. You have to find, or the miners want to find the particular noun's value which produces a hash code like this. Okay. So what's the input that you are giving? The input is that you have to come up with a trial and error method, like a brute force method. Okay, so different nouns values you have to try for, then you can come up with a block hash. That process is known as the mining. So now next is we are moving towards the blockchain concept. You can see that this is a blockchain where this is block 1 and block 2. According to block 2, the previous hash is the hash of block 1, 0001578, right? You can see here. If I try to tamper the block over here, what happens? The whole block hash will change because of the previous hash. Okay, so the hash of block 2 will change. As a result, the whole hash, the whole remaining blocks will becomes change. So my point is that if I try to tamper the data of a single block, what happens? Not only that particular block, the entire block chain becomes invalid. Okay. Next is distributed. Say distributed means there will be multiple users and every user will be storing the same blockchain. For example, say assume that A is a malicious user. Okay, malicious, he tried to tamper the data. What happens? The whole chain becomes invalid. Okay, and he is entirely like the chain that is holding, first thing is that it becomes invalid, and the second thing is that the chain that he is holding is different from other users, right? But the point is, if he has a lot of computation power with him, for example a very good server or a huge computing, a supercomputer, or nowadays we have the quantum computers, right? So a huge computing power is with him or her. He can come up with validating each block. Okay, so once again he can go for mining for each block. Mining, it will take in normal scenario, mining it will take 10 minutes, 10 to 15 minutes. Okay, that means what exactly the miners will do, miners want to find out the particular nonce value for a given hash value. So that we will explain in the coming slides. However, my point is that now please listen that here the blockchain that is holded by A is valid, right? It is a valid chain. You can see this is a valid chain. But what's the difference is that the peers B and C is holding same chain, but it is entirely different from peer A. Say, just analyze that according to peer A, the block hash is 0031FA, but the block hash of peer B is 0012FA, and it is same for 0012FA for the peer C. So here comes the 51 percentage rule. Even if the attacker or a malicious user try to tamper the data, and within the 10 minutes or within 10 to 15 minutes, if we come up with the solution of the block, then there comes the 51 percentage rule, that even if you come up, you have invested your time, your money, or your computing power, then you come up with a valid chain, but nobody will accept your newly validated chain, because there comes the 51 percentage rule. Until and unless 51 percentage of the nodes accept your chain, then only your chain becomes valid. Otherwise your chain is invalid. So that's the reason why the miners or attackers are not encouraged to deploy attacks, or not encouraged to come up with an attack towards the blockchain, because whatever they do, ultimately no one will accept it. So first reason why we are claiming immutability is not possible, the first reason is that if you try to tamper the data, the block hash will change, so that the entire chain becomes invalid. The second reason is that to come up, for example, say you try to tamper the data, so the whole chain becomes invalid. If you want to come up a valid block, then you have to do mining for each block, and for each block it will take 10 to 15 minutes. So the second reason immutability is not there, because it is infeasible to compute block hash of all the blocks in a chain within this 10 to 15 minutes, because 10 to 15 minutes on an average it will take to mine a single block. So just assume that if enormous blocks are there in the blockchain, it is infeasible to compute the hashes of the whole invalid blocks within 10 to 15 minutes. So that's the second reason where it is infeasible to compute the block hash of whole invalid blocks within 10 to 15 minutes. So next is we can say that, say if we can assume that, we are always assume that this attacker or the adversary has enormous power in terms of time or in terms of computing power. We are assuming in that way. If we are deploying these sort of computing, the huge computers or quantum computers or supercomputers, then he parallelly do the hashes, and within 10 minutes he come up with a valid solution for all the block. Then there comes the 51 percentage rule. Even if you invested a lot of money, time, your computing power, then you come up with a valid chain, nobody accept your chain because of the 51 percentage rule. Until and unless 51 percentage of the nodes in the network should accept your newly formed chain. That is infeasible, because in a network there will be millions and billions of node. Okay, influencing the 51 percentage of those nodes is impossible. So in that way, we can state that immutability is achieved in blockchain. Immutability of data is being achieved in blockchain. Okay. So here comes the transaction, right? This is not exactly data. Here it is transaction. Instead of this one, you can come up with this much data, okay, or make it zero. So what happens? The whole chain becomes invalid, right? So I said like I have discussed in a block. It's not exactly like one transaction per block. You can accommodate multiple transaction, and there is no fixed number of transaction you can accommodate per block. Like in the third block, you can see how many transaction, three. Okay, it's completely based on the maximum size of a block and the size of each transaction. Okay, hope you it's clear, right? So in this way, we can conclude our session in such a way that if Alice want to yeah, if Alice want to transfer some transaction, right? Then so the transaction is Alice to Bob, say 10 Bitcoin, then Alice will initiate the transaction. The transaction will be flooded across the network. Then there are some special nodes in the network. We called it as miners. So the miners will create a block. So at that stage, the block is not valid. It's not at all validated. Okay, it's not like invalid. It is not at all validated. Then who will validate? In the network, there are some special nodes called miners who will validate a particular block. So there are special nodes, right? So they want to undergo a cryptographic puzzle. The puzzle is that they have to find a particular nouns value which satisfies the condition. Condition is that the network will place a target hash. The generated block hash will be less than or equal to the target hash. If the condition is true, then the miners will get a monitorial benefit of 6.25 Bitcoin. Okay, and they can validate the newly block, and as a result, so if there is an existing chain over here, they can add the newly validated chain for the existing chain. So once they have updated their chain, they have to flood the newly updated chain towards the network so that everybody will receive newly updated chain. Okay. So in that way, the synchronization problem is being solved, and the whole process will take around 10 to 15 minutes. That means wherever you are sitting or wherever you are residing, you can transfer the cryptocurrency within 10 to 15 minutes. That means Bo will receive the cryptocurrency after or on an average of 10 to 15 minutes. Okay. So that's all. Do you have any queries? Hello?
Yes, ma'am. We are receiving the comments in the comment box. So a lot of appreciation is coming over there.
So you can connect with me through this mail ID.